All right, so for 6.5, we're going to learn a couple techniques that will help us to take derivatives. And to do integration. So for example number 1, that's a 1, it looks like a 7. I have an expression x minus 13 over 2x minus 7x plus 3. Okay. Now to take a derivative, I could use the quotient rule on that, and that would work out, and I can integrate that, but it's kind of messy because of that polynomial in the bottom. So one technique is to separate the fraction into parts. That could be separated into the sum of two fractions. Before I do that, though, I want to remind you kind of what we're doing here. If I take 1/2 plus 1/4, before I could add those up, I need a common denominator. Okay? Now the common denominator can be found by the least common multiple. Now this is a very formal way to do this. We all know that the common denominator is 4, and when you're in like 2nd or 3rd grade, they tell you what goes, what number does 2 and 4 go into? Bless you. But technically what you're supposed to do, the first step in finding the lowest common multiple is to do what we call prime factorization. I ran out of room, but basically I have a 2 and I have a 4. Well, this could be written as 1 over 2 to the first power, and then this could be written as 1 over 2 squared. Remembering that prime numbers are 2, 3, 5, 7, 11, 13, so on and so forth. All the numbers that are only divisible by 1 in themselves. So what we do is we can take any number and factor till it can't be factored anymore. Then to find the lowest common multiple, you write the highest power for each prime factorization. So, or prime number. So the highest power, first of all, the only base we have is 2, and the highest power is squared. So 2 squared is 4. Hey, by the way, that's the lowest common multiple. Well, when I have it as prime factorization, in order to make this 1 over 2 equal 1 over 2 squared, I'm going to multiply this by 2. And that changes it from 1/2 to 2/4. Okay? And then when we add it up, we get 3/4. Alright? So when we see 3/4, we just think, oh yeah, it's 3/4, whatever. But 3/4 could be separated. That's what we're going to try to do today, but instead of using numbers, we're going to use polynomials and algebraic expressions with variables. All right? So we're going to do this whole process backwards. We're going to do this and that. So the first step in that process is to do the prime factorization. Well, the numerator is already prime, so I've got to factor this. For time's sake, I'm not going to go through, you should know how to factor by now. But if I factor this, I'll get 2x minus 1 times x minus 3. Okay? And if you want to later on, you can multiply it out, but that's what the prime factorization of 2x squared minus 7x plus 3 is. So now, the next step is I want this to look like, something like this. F of x is equal to some numerator a over 2x minus 1 plus some numerator b times x minus 3. So we're working backwards now. Well, in order for those to come together, what did we need to add two fractions with different denominators? Common denominator, and using that prime, lowest common multiple, but it's a common denominator, and what we did is we had to take the factors and raise each factor, you had to have the common factors raised to the highest power. So the only factors we have is 2x minus 1 and x minus 3. So this needs to be multiplied by x minus 3. Well, whatever you do on the bottom, you got to do on the top. And then this needed to be multiplied by 2x minus 1. And again, whatever you do on the bottom, you have to do on the top. So at that point, we get a times x minus 3 plus b times 2x minus 1. Now that has to equal what the original numerator was. Okay? And the original numerator was x minus 13. So there's lots of ways to solve for a and b, but it's not easy. Probably, I like the way the textbook does it. What the textbook does is it says arbitrarily choose some value for x and plug it in and see what you get. Now, if I choose the right value for x, I can get rid of either the a or b. Now, what I mean by that is if I let x equal 3, then I get a times 3 minus 3 plus b times 2 times 3 minus 1 is equal to 3 minus 13. Now, by letting x equal 3, what happens is this goes to 0, so this whole term goes away. And I've got 6 minus 1, which is 5, so I've got 5 times b is equal to negative 10, or b equals negative 2. Well, that worked out okay, right? So now I just got to do the same thing for b. I've got to arbitrarily choose some value for x that makes b go to 0. So I think it's 1/2. So if I say a times 1/2 minus 3 plus b times 2 times 1/2 minus 1 equals 1/2 minus 13, well, that should give me something. This becomes a to the a times negative 5 over 2 plus b times 0, right? Because 1/2 of 2 is 1, 1 minus 1 is 0. And this becomes, what is that, negative 25 over 2? It's 12.5, negative 12.5. Well, the negatives cancel, and so I get 5 over 2a is equal to 25 over 2. Well, if I multiply everything by 2, then the 2's cancel, and I get 5a equals 25, or a equals 5. So what did I, yeah, you didn't have to applaud, I was just doing a little gesture there, or whatever. So f of x then, I said was a over 2x minus 1, which is really 5 over 2x minus 1, plus minus 2, which was my b term, over x minus 3. Now my claim is that should equal x. Remember, this was supposed to, this whole thing here is supposed to be x minus 13 all over 2x squared minus 7x plus 3. That's what it's supposed to be. How can I verify to make sure that I did my work correct? Multiply it out. So if I take this and multiply it by x minus 3, whatever I do on the bottom, I have to do on the top. This I have to do the same thing, but I'm going to multiply it by 2x minus 1 so I can get my common denominator, right? That gives me, whoops. This gives me on the top 5x minus 15 minus 4x plus 2. And then that is 2x squared minus 7x plus 3. Okay? 5x minus 4x is just x. And then negative 15 plus 2 is negative 13. Was that correct? Yeah, it was correct. So here's why we do all that. We could take the derivative or integrate f of x as that, or it's a lot easier to just say 5 over 2x minus 1 minus 2 over x minus 3. So it's a lot easier because then I can integrate by parts or differentiate by parts, so, or each term, the monomials, right? So that's the first step in the process. Any questions? Okay, good. Good.